Hi, I'm Storm West at the Phoenix Learning Center. During this lesson, I will use Lewis dot structures to explain both the bond and molecular polarity in molecules of the 7 diatomic elements. Let's begin with some background information. Diatomic elements are chemical elements whose stable form at STP consists of diatomic molecules. These elements are so reactive that the individual atoms of these elements cannot exist alone. But by pairing with each other, the atoms of these elements will form a stable electron configuration resembling the subsequent noble gas on the periodic table. For example, hydrogen will achieve the electron configuration of the noble gas helium, and oxygen will achieve the electron configuration of the noble gas neon. The 7 diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Most diatomic molecules will contain a single nonpolar covalent bond, but diatomic molecules of the elements oxygen and nitrogen will contain multiple nonpolar covalent bonds. And since diatomic molecules of these elements are clearly symmetrical, the molecules of these diatomic elements have an even charge distribution, and therefore their molecular polarity is classified as nonpolar. Let's begin with the simplest diatomic molecule, the diatomic molecules of the element hydrogen. Because the nucleus of a hydrogen atom contains but one proton, hydrogen is the only nonmetallic element that is located on the left side of the periodic table. When writing a Lewis dot structure for a molecule of this diatomic element, we begin by writing H2. We then separate the atoms and count the total number of valence electrons, which will be 2, since each atom possesses one valence electron each. We now connect the two atoms via a nonpolar covalent bond, which consumes the 2 electrons, leaving a total of 0. This creates a stable molecule where each atom will now possess the electron configuration of the noble gas helium. The halogens represent a special case. All halogens are found in group 17 or 7a on the periodic table. Therefore, the atoms of these diatomic elements will all possess 7 valence electrons. It is customary to use the general symbol X2 when writing the Lewis dot structures for diatomic molecules of these elements. We separate the atoms and count the total number of valence electrons, which will be 14. We connect the atoms via a nonpolar covalent bond, leaving a total of 12. At this point, most students will be tempted to divide 12 by 2 and give each atom 6 dots to complete the octet. However, the proper technique to use is to satisfy the atoms one at a time. So let's begin by satisfying the atom on the right first by giving it 6 additional dots, since the nonpolar covalent bond represents 2 electrons. This leaves 6 electrons, which are now placed around the atom on the left, creating a stable molecule. The diatomic elements found in group 17 are fluorine, chlorine, bromine, and of course, iodine. Two out of these 7 diatomic elements consist of molecules containing multiple nonpolar covalent bonds, the elements oxygen and nitrogen. When writing the Lewis dot structure for a molecule of oxygen, we begin by writing O2. Then separate the atoms and count up the total number of valence electrons. Each oxygen possesses 6 valence electrons, so the total will be 12. Now connect the atoms via a non-polar covalent bond consumes 2 of the 12 electrons, leaving a total of 10. At this point, students are often tempted to divide 10 by 2 and placing 5 dots around each atom. However, the correct way to complete the Lewis dot structure is to satisfy the atoms one at a time. At this point, we place 6 dots around the atom on the right, creating an octet for that atom. Remember, the non-polar covalent bond represents 2 dots. This leaves 4 dots remaining, which are now placed around the atom on the left. Since the atom on the left does not yet possess an octet of electrons, the molecule is unstable. To stabilize the molecule, simply share 2 electrons from the atom on the right. This creates what is called a double bond, and after adjusting for the geometry, we have now created a stable molecule. The element nitrogen also contains multiple nonpolar covalent bonds. When writing the Lewis dot structure for a molecule of nitrogen, we begin by writing N2. Then we separate the atoms and count the total number of valence electrons. Since each nitrogen atom possesses 5, the total will be 10. We now connect the atoms via a nonpolar covalent bond consuming 2, leaving a total of 8. At this point, we now satisfy each atom one at a time. After placing 6 additional dots around the atom on the right, we've created a stable atom of nitrogen with an octet of electrons. The remaining 2 electrons are placed around the atom on the left. This clearly creates an unstable molecule. The atom on the left now only possesses 4 valence electrons. To stabilize the molecule, we first share 2 additional electrons from the atom on the right, which creates a total of 6 valence electrons for the atom on the left, still an unstable molecule. After sharing an additional 2 valence electrons, both atoms are now stable with an octet of electrons. Nitrogen is the only diatomic element containing a triple bond, and we now have created a stable molecule of oxygen gas. This concludes my lesson on identifying the bond and molecular polarity in molecules of the 7 diatomic elements. If you would like to make a contribution to our campaign to provide quality online lessons, please visit our Facebook page at www.facebook.com/WPHS Chemistry, or go to GoFundMe at FAW9T82C. Hopefully this video has been helpful. Thanks for watching.